Hi all, Ivan is here and I'm continue working and experimenting with the Serde-flow library, the library that helps you convert from different serialized binary objects. So it helps you to migrate your serialized objects in Rust. So yeah, I'm back and I am trying to configure it a little bit the stream, but yeah, I just set it up with some stuff, but I'm spending so much time on it and it's a bit tedious to configure all this stream things and trying to jungling between Twitch and YouTube, but fine. I want to write code, I want to stream it. That's what I'm doing now, and I want to play the games sometimes and also stream them. So let's see how it goes and continue with this part. So we finished with our bench test when we compared that. What compared? Yes, we compared the bin code with check and the pure bin code. So the idea was before that to use some kind of verification that we are storing on the disk exactly the same data that I serialized. Right? It's pretty much simple. So here we have a checksum calculator and a calculated, so we have a function, serialize check, and this function use the serialized bytes, and the bytes serialized by the normal Serde bin code serializer, and use these bytes to calculate the checksum. Then the second one, we store these bytes on the disk, then we read them one more time, calculate for them checksum, and comparing the checksum of the serialized bytes and what is really written on our disk. Then we can say that it's the same data or not the same. And I want to work on that. I want to continue that and expose that in the functionality of this library. Let's see how it's organized. I would say the good way to look at this library is check at tests. So, and how we can check tests? The basic migration. And in the basic migration, you can see that we have a couple of objects or structs here. So we have a user struct and we have a couple of variants, right? Variants v1 and variants v2. So, and a couple of from implemented for them. Maybe it's a bit cumbersome for the test data, and I think exactly the same, but that's how it works now. Then when we have a variance, what we can do, when we have variance, you can see that we use the function save to path, and this function accepts like a parameter the serializer and serialize that on disk level. That's it for this part. And then we have a load from, and for the load from we can serialize user v1. You see, like here we have a user v1. This user contains only first name and last name, and then we try to load from pass just the user, and then this user will be converted from this user v1. And for that reason I implemented the derive implementation. Here we go. Yeah, I know. It's by the way, what does the error says? More than 3 pools and a struct, consider. I like to have them. Maybe later I will fix them, or I will research. Maybe I'm doing some of them wrong, but it's very, very verbose, clippy, and very pedantic way to verify your code base. Let me turn off my stretchy, because it will tell us many times that I need to look at somewhere. I use it all the time because sometimes I'm too focused on the programming and I want to be distracted sometimes a little bit. So yeah, let's continue. So I'm going to work on this library in the streams. We'll see how it goes, but I definitely want to work out. And I know that there is a mistake in this version of this library, because it's mentioned a different library of mine. You didn't see that, it's just on top of my mind that I said, but never mind, later I will show you. So we have this flow derive function here. Here we go. So here we're parsing our tokens and start generating them. And what is generated and how it works, let me explain. For each version here, when you have a version number, here you have a version number 3, and this works in a way when we generate the constant for that and set the constant, and then we use this constant for the objects to convert from. It's better to show it variants and how it works. Here we go. So here the component load from, and we use this tool to generate the constant, and constant looks like this: flow ID and the name of the struct in uppercase format, and we use it to convert from. I think the better way, I know how to show it. Yes, here we go, and I know that what you would like to see. Let me switch back on my webcam. I know that you will like it, and let me check how it works. Nice, back. Now you see all of these keystrokes that I am using. I totally forgot about that in the previous time, but now you will see that, right? I'm doing nothing, now you see that. Okay, what I can do, so, and here I want to use flow, and inside flow I just use the flow, then run. Let's run the test. Doesn't matter which one, all of them. Have you seen that? We generated all of this code parts. I will show you. My mouse, okay, fine. Never mind about my mouse. Anyway, we're using a Vim, right? You don't need a mouse at all. Okay. I want to find some good example. Looking for a very good example. Is it a good example? Does it? It's asynchronous, because I have a synchronous and asynchronous, but I think with asynchronous it will be a bit simpler. Car ID, which one? A 3, yes. The conversion from, yeah, good example. Let's copy that. It's yeah, it's formatted badly, but what we can do, we need to find the car. It was a car or not? Let's see. Yeah, it was a car. Zero copy. But it's fine. Let's see. Let's see how it works. Yeah, no, a lot of errors. Basically, it creates the load from function, and this function verifies the path, then load the bytes, and verifies that there is more than 2 bytes, because if it's less than 2 bytes, it means it doesn't bring anything about the type, the variant, and the variant is then encoded number, unsigned 16, so it's 2 bytes of the number encoded inside of your binary, and I can use this. The library uses this number to decode your object. Then you can see it decoded this only for the zero copy. For not zero copy, it happens a bit differently, but for the zero copy, because it's a unique Rust format with the archive, I used the unsigned 16 to read to convert that from 2 bytes of the whole file. Then I read them and speed off first 2 bytes into bytes, yeah, of course, and then you can see how it works. First of all, the 3 unsigned 16, of course, this is my type. Then I want to, it's a very good example, but I want to show it with a real file. Let me I will remove it from great. Fine. Save it, and this came from zero copy. I think zero copy basic migration. Here we go. Cars is here. 36. Now I want to do that after from, before test. That would be nice. Okay, here we go. So you can see how it works. We have flow ID, then we use the match, the pattern matching. It should be really fast. That's what I'm expecting from it, because the match is really fast, especially on the numbers. And this is a constant. Flow ID car value 1, it's a constant, and the number of this constant came from this number. So it's purely numberal. And what happens next? This especially happens only for zero copy, because if it's the flow ID car value 1 and it's recognized that it's a different format, we have a problem, because deserialization doesn't happen for zero copy exactly here. And I'm creating a new reader of the old object, because I know the format. This is a car variant 1, sorry. And then I convert it, so I just call the car from the old object that I deserialized here, because you can see I use the deserialization. It's not a zero copy, it's a real deserialization. Then I convert it and then save to path and load from path again. And for the save, you see, I use this number in a function. I know that is a third, that is the third variant, and I put this 3 number inside of this little bytes number, and then store them with this number on a disk. Pretty much simple. And also have a migration functions is simple. If I want to load and migrate, yeah, it's very redundant for this type of thing, but yeah, maybe I have to reconsider it in the future. And for the migrate, I just load from, because load from does the migration to me, but it doesn't happen with the normal, with the Serde, I mean. And let's find the Serde. Should be somewhere here. User ID, Serde-flow. Let's say user. Should be somewhere. I think so. Yeah. Never mind. But you can see how it works. I will copy and show you. Basic migrations. We are back again. Now you see the float ID user is just a number. That's why you have to keep them in the one file, because the constants lives in the one file and don't use any package specification for them. Okay. Then I implement the struct. Let's save it. So how it works? I have a constant, then I have a struct, and inside of the struct you see exactly the same fields, so first name, middle name, last name, but one field more, and this field is a flow ID. Then what happens? I create a flow ID, use the flow ID and the old object. Yes, I'm copying from all these fields. It's not very efficient, and the all fields must be clonable. But yeah, it's efficient in a different way, because it provides you the ability to be secure enough to store everything on your drive and then read it one more time. Then we have a file for the user, and load from file, again check path, and then read the bytes, verify that there is enough memory there, then there is enough length in these bytes, and then I deserialize them. But how? I deserialized only flow ID, and the flow ID it's just a simple object. And how it happens? The Serde, when deserializing your object, read the first field, and the first field of this struct is a flow ID, unsigned 16, and you can see here flow ID, exactly, unsigned 16. That's how it works. And then what happens next? It's pretty much trivial. I use the flow ID, and then I deserialize the whole object, so it's a user flow ID with the other fields. And then, of course, I can do the first of all user version 1 from this object, and then I'm doing the from for the user and return this. And look closely at that. In this function, I don't have any migration tools. It's just a reading. So when I read the user, it's converted from user version 1, but on a disk, still user version, when I read it, and for example, on a disk is user version variant 1 is written, then during the reading, I converted this to the user, to the normal user, the updated, modern, and the user version variant 1 exists on the disk, and it remains on the disk without any changes, because you need to rewrite it. It's only for zero copy happens, because you cannot do the zero copy with the wrong object. You need to copy, and that's why I decided to overwrite it in a load function. Maybe I need a different behavior. I will think about it later, but for now that's how it works. And that's why I have this migrate file migrate trait, and inside of this trait I read them. So I read the user, and then I save the user on the disk and return this type of the migrated user. Or you can migrate, and during the migrate I just load and save the user and return nothing if you don't need the user, if you want to migrate the whole folder. That also works for you. And you have something more here? No, nothing. And let me select all of this. Yeah, maybe I can find more thing. Yeah, you can see how the from works. So I generated this from, and inside of this from you can see that I'm copying just everything except the flow ID. Pretty much it. Oof, everything. Scroll. What I want to do next? It's a very good question. I definitely want to remove it. The test set. Nothing is broken. What I want. I want to work on this part when I want to verify the checksum, because it brings the security, and I'm developing this library especially for security purposes, for safety purposes of the type of things that I'm working on. I want to have it very securely. I don't think that these written things will be happen very often. That's why I have this luxuriously time to verify the checksum. And yeah, so for that reason I want to move it somewhere. And probably I need to provide the proper error there. And I'm thinking, do I need to try and write this down one more time on a disk level? So if I'm deserializing something, it's fine to deserialize something, but I have to think, should I try to write on a disk one more time? And if it's valid, then return the error. So to have kind of a backup. And if so, how many times should I try to write something on a disk? That's a very good question. And then, what does it bring to me? Is it even possible to break something on a disk level? I mean, during the write, is it possible to write down something wrong? I don't know. But I know that I don't have splash screen to refill my Neovim cup, because I want to drink a bit of water, but yeah, I don't have the screen for now. Let's continue. Where I can do that, I have a couple of places. The first of all, I can do that in load from path function. Here I have a function. Let me think. So here I have as deserialization, right? No, it's deserialization, but I want to save to path, right? Save to path. It's here. Save to path. Function body. I calculated the function body for that. Right. I'm trying to think about it. Should it be inside of the encoder? Where? I have this memcopy thing, but I don't think that I need to have a memcopy now. I want to remove it. Also, yeah, I think I will put it inside of the encoder. I'm thinking where to put this. Go here. And also, I don't know which one should I use, the x25 or the unsigned 16 or unsigned 32, but I think a 32 possibly can be the overkill. Let me Google it. Oops, sorry. Nothing. What? Okay, fine. I wanted to Google it, but yeah, never mind. Maybe I will change it later. I just think, what is the difference between x25 and the unsigned 32? What I'm expecting that you have to spend more time to calculate the longer one, right? Maybe, or maybe not. I will take the longer one. So copy that. No. Okay. Now we have the body, and we can use it directly here to calculate a checksum and calculate it later. How should I do that? In a loop? So I will try that to write it down in a loop. And if I try to calculate that inside of the loop, what happens next? Yeah, I'm thinking about this functionality. When you have the total bytes, then I have checksum, right? Checksum. I can easily calculate the checksum, use the Serde-flow encoder, and inside of the encoder I have this weird name that's castagnoli. Copy. Here, right? What I can do, I can call checksum. Checksum. Should be here. Total bytes. Attempts. Let's say 3 is a good amount of attempts. What do you think? Then loop, inside of the loop. Trying to write it down. Yes, yes. I'll read. No. Bytes. Not the total bytes. Just bytes. Yeah, it's fine. It's fine. Total bytes. Bytes. Definitely need to add times. This one. Come on, it's not the file read here. Come on. Read component generate file system read. right? Okay. So, while attempts more than 0, and the file write, then file read, and then return checksum flow quarter bytes, right? And now if checksum equal to the written checksum, okay, and return okay. Out, that's fine. And then I need a Serde, I need an error. Error. Bytes in the disk. Valid right. That's what I think. Valid to write. Valid to write bytes on the disk. Just repeat it. I don't know why I repeat it for my future myself, and I definitely forget what does it mean. I don't know. But here it should be the error. And the error should be the Serde-flow valid to write. Yeah. Serde-flow error should be there. Serde-flow error, right? Valid to write. Let me check. So here, valid to write. Right. This function will be generated for all of our, for almost all of our save. Scary test. Okay. At least we have some kind of error. Oh yeah, surely. Everything works. So we're calculating that checksum. For sure we did. Then we use the while loop to try 3 attempts to write it down. And if it's failed with 3 attempts, then we're returning the failure to write error. I would say it's a pretty decent setup. We're doing a lot of work trying to be very secure, so we're calculating, not as secure, but very failure oriented. And I would say, yeah, failure oriented. Okay, I like this approach. Maybe we have to research it further about the save to path async and the same functional body. Yeah, it's exactly the same, right? But how it works? If it's the same, but yeah, surely. And also, do we want to have it all the time? Maybe sometimes you don't want to have a more EO operations. I don't know. We have it for async, not async, but we don't have it for the zero copy. Thinking. Okay, no. I implemented that for zero copy, not for the normal one. Now let's do that for the normal one. I'm thinking to move it under the parameter when you can turn on or turn off this thing. For example, it does, yeah, it's really easy to reuse. That's what I think about. This is quite easy to reuse, right? Right. Okay, yes. It's easy to reuse and we can reuse it whenever we want it. Okay. Also, by the way, I have a standing desk, so I can even marching, but I'm staying. It's quite nice for the health, I think, to have a standing desk. And sometimes you can be standing and sometimes you can sit down and relax a bit. That's what I'm going to do, playing the game next. Let's do the function for that. I think it would be the appropriate behavior. So we need to create the parameter, and for the parameter I want to extend this part, so flow generator. Let's say verified safe. It's definitely verified, right? Yeah, verified write, I would say. It looks like a verified write, but what I have to do? Verify write. Okay. Now we have this. I have somewhere the parsing. Definitely here. Let me see the references for this. Here we go, here we go. Is verified right, false by default. But if it's false by default, then yeah, I need to implement the bytes. Yeah, sure, I will do that. I will do that. Let's do that for the zero copy. Come on. Zero copy. Here we go. Am I here? I think it should be the part of the file here. Right? When I want to store something on a disk, it's all the time must be a file indentation. So then I can use the name. What kind of name? Let's say verify right. Is verify right set true? Correct. Then we need to look at the generation of the components. Let's rename it just component fs reads 19, please. Come on. Component fs write. Good. Let's see how it works. So verify right. Okay. Self is blocking. I want to use the blocking. Return proc macro 2. So can stream. Return nothing. But if it's not nothing, then I want to have that func create please. Then self components fs reads. Yes, fs is blocking, right? Right. Now I have func read, func write, and right about to start. I would say almost correct. Now, before parse, here. Quote. Alright. Almost. File read, please. And no. File right. Come on. File read, file write. Good. It should be a bit different. Should be quotes. Okay. Seems good. Pretty much. So now we have a verified write. Let's back. It was right here. Save to path. Exactly here. Don't need to care about. Can't believe the function body is exactly the same. Okay, fine. Okay. Verify write self component. Nah. Verify it right. It should be a component. Name it right now. Come on. Thank you. Component verified right. Just to say that it's possible, we can empty try verify right. Here we go. File right. No. Try verify right. I already see the problem. Let's use it here. It's absolutely right. Remove it. Move it completely. Where am I? Am I here? Look. We need to still use the file right here. Correct? Correct. Because we completely removed the type how we saving things. So it's a approach to write or data on a disk, and we completely rewrite it using the generation. For that reason, we need to use it, so we can completely get rid of it. Component verify right. Use it here, and we use it here, and it doesn't matter of the body, right? Let's test it. Mistake somewhere. Where? Yes, it works, but it works. No. Yes, I'm here. Let's look at them one more time. Separate them. Go. we have a lot of codes. Test, I don't care. Load from, save to, normal bytes for the car. Is it a sync? Is it a sync or not? Do you see any awaits? Save to path. No, it's a normal one. But I'm too excited to test it. Okay. We need to go on some tests. Go in basic migration, zero copy, blah blah blah. Go in the basic migration here. Verify, right. Exactly. Time. What? Okay, and use JSON. I get rid of it. Now, no JSON at all. No migrate. Yes, I need to implement it, but later. Macro serial exited with code. I don't give a shit for now. It's some problems. Load and migrate. Function I said not found in user. Let me think. Cargo. Thinking what I can run. Basic. Can I do something like that? Yes, can. Why car test? Again. Let me investigate. Save to path. Zero copy. Blah blah blah. This is the first user. Not from save. It's a normal save. Save 2, is it a normal? It seems normal. Right bias. Normal one. Okay. If is verify right is false, return verify right under the file. Calculate checksum, write and read, verify the checksum, write at the back. Am I returning it? Yeah, sure. Read write. Seems fine by me, but it doesn't work for some reason. It's reachable. Proc macro serialize not expanded. Server exited the code. Safety path not found for this struct. Verify right. Works without it, right? Like this, can test it. It works. It works. Verify right. Block. Function or associated item not found in user. But it should be there. Ah. Function is associated and found. Okay, I'm going to sit down. Looks complicated a bit. Car migration. Car. User. The sync user. Why not? Verify. Verify one more time. Ah. Basic migration. Migration. Too many braces. Go. It must be here, but it's not here. Oh, here we go. Okay, it's about the cars. Let's investigate. What is the problem with that? So we have attempts, checksum, calculated checksum, set temps, wow. Read the bytes, then we calculated the written checksum, verified. Don't get it. Maybe the problem lies in a different part of it. Should be something simple, but it doesn't work, and it recognizes that function or associated item not found in the user. So the problem with the user. Thinking how it should be. Sure, it should be something file. No, it should be file user. Here we go. This one. It's a sync? No, it's a normal one. It's a normal user. What is going on with this normal user? So we have basic migration here. I don't see any criminals, any critical things here. To me, it seems all of this seems fine. Write it down. I use the bytes, use the path. You're doing okay. And if it's not, but it must be a new type of thing. Basic migration. Why? What is a not trivial error? If is verify false, then return normally. But it's false by default. And only if file is provided, and if it's indent true, then return it true. Do you have any mistake here? Or it returns error, origins okay, temps -1, if they are equal, left. What I don't understand. No errors? Are you kidding me? What if only for the user verify right? only for the one user. Do you have any other users? Yes, I do have a verify user. And basic migration. Only one. Go. User. Thank you very much. Hello, user. What if you don't have this field? Yeah, like that. But I asked to verify the rights. False by default, okay. Try verify, okay. And I use the try verify for both of them, for save to pass, for function body. Okay, for zero copy and not zero copy. By the way, it's incorrect. In the second way, it should be this. But it's true for sure. Verify right. Maybe I mistyped somehow. I don't know. 35. Verify right. False. False all the time. Inside of the file, if the file meta contains the path verify right. Verify right. Then is verify right true? Look. Okay, what if I remove it? Under the file, right? Yes, under the file. Is file true? Okay. For struct. Okay, his user is verified, that's true. Okay. Or save to path is slash body. But oh, okay. For self struct name. Aha. For user. Is true, but I didn't see any type of while. Aha. Okay, save to path. Function body. The user feels true. And if it's true, where it is? It's pretty late. Is verifying, it's true. Okay, for user one, save path is. And it's incorrect. Not for the user one. Yes, it's for all of them. It's correct. Where the user is. If it's false, then return this part. Name. Something like that. Go test it. Wow, I even don't see the user here. Is verify right? True. Is verify right? False. False, 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 false. Maybe. I think I have some kind of idea in my mind. It's not very trivial, so we'll see. Now it's fine. And it's fine, why? Scroll, show me. And now the user is verified right, false. I have only one idea. Test it. Is verified, right? Tell me. It's set this here. What else? I do this. Just the last idea, because I don't really understand why it's going on. Will be else if. One more time, else if. Only this I have in my mind. No idea why. Verify right. Next. Go. Tell me the truth. Why it's so strict? It works. It's not blocking true, it's verified true. I need to research that later. I don't know why it's happening. I'm finishing the stream. Thanks for watching. I'll research that later, but I definitely want to have this functionality. Probably it's some small typo that I can't find it so easily, but I don't know why it's happening. I need to research that a bit.